Hamilton Lee and Zoltan Chaki present iHeart Embedded. To create iHeart Embedded, we used an external accelerometer and an 8x16 LED matrix. Using the data from the accelerometer, we animated the vibrations detected on an LED matrix. This was done by creating a line graph that flows across the LED matrix. A flat line represents no acceleration. Points above the flat line represent positive acceleration, while points below represent negative acceleration. The original intention of this project was to be able to read and display a heartbeat by strapping an accelerometer to your chest and detecting the vibrations from your heart pumping. Unfortunately, this did not work due to the high amount of noise and error in the accelerometer outputs. But as you can see, we created iHeart Embedded to detect and display a simulated heartbeat that is generated by tapping a finger on the heart. iHeart Embedded is very versatile and can be used in many other applications. These include, but are not limited to, breath rate monitoring and vibration analysis, including detecting footsteps from the environment.
So for this project to work, we had to integrate an ADXL335 accelerometer and an Adafruit LED matrix. To set up the accelerometer, we used 3 analog pins to read the X, Y, and Z acceleration. After this was done, base readings were taken from the accelerometer to calibrate the system. This allowed us to write a function that could convert the raw 16-bit ADC ratings to a G-force based acting on the physical system. After calculating the G-force, the magnitude of the gravity vector is subtracted to ensure any readings are coming from external forces on the system. To animate the LED matrix, we used an I2C protocol. This allows us to send 2-byte instructions along with 1-byte instructions to allow us to calibrate the LED matrix and send instructions to turn on specific LEDs on the matrix. 1-byte instructions basically set up the LED matrix, allow us to do things like turn on the clock on the board and also set the blinking rate for the LEDs, while the 2-byte instructions basically turn on the specific LEDs that you want to. So for the first byte and the 2-byte instructions, you send the address, and the second byte sends ones and zeros, which tell which LEDs turn on specifically.
In order to animate the LED matrix, we created a custom data structure that was represented as a linked list where every node represents a column. Each column has the bit values for the lights that should light up in that column and a pointer to the next column that should be animated. After a specified time value, a new column is inserted into the linked list based on accelerometer readings, and the last column is removed. This causes all the columns to be shifted over and creates an animation. In order to draw the custom data structure we created on an LED matrix, we had to create a recursive function using bit shifting to light up the LEDs in the corresponding rows from our column form. Thank you for watching.